Good evening, Himanshu. Good evening, Himanshu. I'm fine, thank you. Very nice timing was. Switch on that side fan, huh? Good evening, Chahil. Yeah. Shall we start the class, please? Good evening, Arunisha. Good evening, Ruchi. So today, atoms and molecules, some very important part today. After evening also class is there, Ruchi, for you. New chapter I'm starting. Okay. Huh? Now we are doing atoms and molecules structure. We are going to time will be 8 o'clock, 8:20. Most probably 8:20 it will start. Okay. So 8:20 time chapter will start. That's mandatory. That's fixed. It is not going to change. Yes. Now look here. So when we are talking about atoms and molecules, we had learned many things. Actually, we are now going to learn crisscross rule, the rules of making bonding. So discussed, we have discussed means one single part will be called as, I sent the link in the group also, auntie, super beta, thank you so much. So now listen, what we are going to do here is, already we have learned about valency. After learning valency, we learned another important point, and that important thing what we have understood is how we are going to name it: electropositive, electronegative. Okay, electropositive and electronegative, everything we have learned. Now we are going to go for the prefixes are needed in naming binary molecule compounds in those cases where the same two non-metal elements forms a number. So here now these rules you must remember. Okay, so one by one we will learn the rule very nicely, because these rules are the one which will exactly help in naming a chemical compound. You need to take some gap and understand it very nicely. Got it? So now first is, molecular compounds are formed by combination between two different non-metal elements. While writing the formula of molecular compound, the less electronegative non-metal element is written on the left side. Remember this one. Remember this section. This is the most important part. Please remember this section कि when we are writing molecular formula. See, molecular compound when we are writing by combination of two different non-metal elements. So two different non-metal elements means generally they will be sharing. They will be sharing. So when we are talking about two different non-metal elements, then how we are going to deal? While writing the formula of a molecular compound, the less electronegative non-metal element is written on the left hand side. Where it is written left hand side, the less selective electronegative will be written which side? Left hand side. Understood? Whereas the more electronegative non-metal element is written on the right hand side. In naming the molecular compound, the name of less electronegative non-metal is written in such a way so that name of more electronegative element is changed to have ending "ide". Okay, now you need to understand one thing here, that if somebody will be talking about HCl, so when someone is talking about HCl, is named as hydrogen fluoride. Here chlorine is changed to chloride. Why? Because it is exactly what? More electronegative. It is more electronegative. It is not less electroide. What is the meaning ide? Ide is a name. Ide is a pattern of writing the name, beta. Ide is a pattern of writing the name. So when we are using the word ide, that means we are exactly writing the name in terms means the one which is more electronegative and the one which is less electronegative. So 100% hydrogen is less electronegative. So that is, it is written in the left right part and this part is coming in the left. So when it is exactly coming in the left side, how we are going to it? The chlorine is more electronegative. So we are using the word ide for chlorine. Remember this one. Ide for chlorine. Now here sulfide. Understood? So he is more electronegative. Sulfur. So we are using the word sulfide. What word we are using? Sulfide. I hope you might have understood. So we are using the word what, beta? Sulfide. So this is what is most important. Now we will go for the next important part. When there are more than one atom of an element in a molecular compound, then the number of atom is indicated by prefix. So how we are using a prefix here? See, here more than one atom is present. Just check this one out. So if one single will be there, it is considered as mono. Understood? First, we check which one is more electronegative, which one is less electronegative. The one which is more electronegative, yes, the one which is more electronegative, name will be given according to that. Understood? Like among hydrogen and sulfur, sulfur is more electronegative and it is presented in the last na, so ide. What word we are using? Ide, sulfide, chloride, bromide, iodide. Understood? Huh? So that's what we are going to oxide. For oxygen also what we are using? Oxide. For fluorine what we are using? Fluoride. Understood? For bromine what we are using? Bromide. For chlorine what we are using? Chloride. For iodine what we are using? Iodide. So like that part we are exactly using. So now here, but they are telling that, okay, we can talk about their combination, but their combination is not only mono. Sometimes it is more than, correct na? So when hydrogen and chlorine are joining together, hydrogen is less electronegative, chlorine is more electronegative. So what we are using the name? Hydrogen chloride. Remember, what we are using the name? Hydrogen chloride. Very good. Good evening, beta. So now when we are telling magnesium chloride, understood? So here magnesium is added with what? Only one chlorine. Yes, only one chlorine. No, magnesium is added with two chlorine. Understood? But what we are using the word? Magnesium chloride. What we are using the word? Magnesium chloride. And just understood not? So when we are using the word like that, sometimes prefix is added. So how we are adding the prefix? That's the most important thing. Mono, di, tri, tetra and penta. Mono, di, tri, tetra and penta. So how? When only one single will be there, one single electronegative will be there, then mono. Two will be there, di. Three will be there, tri. Four will be there, tetra. Five will be there, penta. But how we are going to check? Now see, among carbon and oxygen. Got it? So we know that after carbon comes oxygen. Understood? So definitely oxygen is more electronegative than carbon. So oxygen is exactly, because you see, you need to check this one out. Who is more electronegative? Because in the periodic table, on going from left to right, definitely the periodic table will be exactly, the periodicity is exactly going to increase. I hope you might have understood here. So here I am talking about my right and left. So some confusion is there. So I am going to clear that out. So this is left and this is considered as right. LHS is equal to RHS. Come on, come fast. So LHS is equal to RHS. So when we are talking about LHS and RHS, now look here. Take care of this part very nicely. When we are talking about LHS and RHS section, so how we are exactly going to check this part? Come on, see this section. LHS and RHS will be there. Then LHS will be less electronegative and RHS will be more electronegative. But I just went by my hand right and left. Okay. So hand is different and this part is different. You take LHS this side and that side is RHS. Ruchi, everyone, is it clear? LHS this side, RHS that side. LHS is equal to RHS. Oh, confusion. So you just take this side LHS and that side RHS. So RHS is more electronegative. Correct na? So that section when we are writing, yes. So that section when we are writing, how we are going to proceed the part and write, just check this one out. Now here, carbon monoxide. So when carbon monoxide will be written, so carbon monoxide, here you check, this is more electronegative. This is more electronegative than carbon. Understood? Chlorine is more electronegative than phosphorus. Again, chlorine is more electronegative than phosphorus. So here you see this one, the one which is less electronegative, it will come as first. Got it? So here carbon, how many oxygen is there? One. So it will become carbon monoxide. So on this name only, this name is going to come. So it is come as carbon monoxide. What happened, beta? What problem came? So that is considered as what? Carbon monoxide. Now one more time check. So here phosphorus, less electronegative. So we are writing phosphorus full name. We are writing phosphorus full name, and after that write phosphorus trichloride. Phosphorus trichloride. Phosphorus what? Trichloride. Understood or not? So phosphorus is coming with trichloride. I hope you might have understood. So this is the most important thing. First part is coming now, penta. Phosphorus pentachloride. What is that? Phosphorus pentachloride. Phosphorus means this first one is less electronegative, full name you write. And after that, how many atoms are there? 5. 5 means penta. So phosphorus pentachloride. Now next one is coming carbon, same carbon, right? After that, how many oxygen is there? 2. So carbon 2 dioxide. Ide. You saw an ide. After that, CCl4. C means carbon. Chlorine electronegative more. So what you are going to write? Tetrachloride. Understood? Carbon tetrachloride. Write down this one very nicely, because the one which is less electronegative, one is more electronegative. How to write this part? This is the most important thing you must learn. The one which is less electronegative and the one which is more electronegative, and how to write that part is very, very important. This is C, carbon tetrachloride. Got it? Here carbon dioxide. Oxygen 2 means di. So carbon dioxide, carbon tetrachloride, this is exactly coming, and this is the way of writing the content. I hope you might have understood. So this is exactly the way of writing the content. Tetra, di, tri, like this, it is exactly coming. I hope everybody might have understood how to write this one. Come on, say. Done? Understood? Done? Super. Yes, this is one of the most important thing. Any type of competition means this is exactly considered as a pillar. This is the most important part. This is considered as pillar part of it. Okay. Now prefixes are needed in naming binary molecule. This is most important thing. Remember this one very nicely. Prefixes are needed in naming binary molecular compound. In those cases where the same two non-metal element form a number of different compounds. Now how we are exactly going to say like that? So now look here. So binary part. Binary means what? Binary means where two different elements are involved. It is considered as binary. What did I said? When two different elements are involved. Tomorrow. 100% tomorrow I'm going to teach Heron's formula. Okay? Yes, tomorrow I'm going to teach Heron's formula. 100% confirm I am going to teach Heron's formula. The same two non-metal element nitrogen and oxygen can combine from 6 different compounds such as nitrogen monoxide, nitrogen dioxide, nitrogen monoxide. Can you see beta how many elements are there? 2 elements. How many elements are there? 2 elements are there. And how we are naming it? Can you check this one out? Learn this one nicely. This is the most important thing. What is the content given? The prefixes are needed in naming binary compounds. So prefix writing is very, very important for binary compound. How the prefix writing is very, very important for binary compound? Let's check this one out. So here same two non-metal elements are exactly present in nitrogen and oxygen if there. So here you see it is called nitrogen oxide. Nitrogen oxide. But oxide we can't say, we can say monoxide, because only one single oxygen is there. So when only one single oxygen will be there, it is considered as nitrogen monoxide. How it is, we are calling it as nitrogen monoxide. When two oxygen will be there. Yes, you might be reminding me, then I could have kept the class for you. So now two different metals combines. That's why two different is there means it is called as binary. When two different will be there, two different metals will be joining together, it is considered as binary. It is considered as binary. When two different metals will be there, it is considered as binary. Okay. Different metals coming means here it is considered as what beta? Binary. You remember this part. It is considered as what? Binary. So remember this one. It is exactly considered as binary part. So I hope you might have understood this one. This is considered as what? Binary. So now sodium. So now here you see how we are going to call it as nitrogen dioxide. But here nitrogen is there in two format. So what you are going to dinitrogen monoxide. Dinitrogen monoxide. Now here dinitrogen trioxide, dinitrogen tetraoxide, and dinitrogen pentoxide. So it is necessary to use prefix in such cases because here nitrogen is not one. Here nitrogen is not one. Here nitrogen is more than one. So when you will be seeing that the main element also will be exactly in the less electronegative element is also having more than one atom, then we have to use prefix for them also. We have to use prefix for them also. So here we have used prefix for nitrogen. What we have used beta? Dinitrogen. What we have used? Dinitrogen. Because how many nitrogens are there? Two nitrogens are there. So it is called as dinitrogen. And here what is there? Nitrogen oxide. Here nitrogen dioxide. But here what? Dinitrogen oxide. Say Kanishk. Dinitrogen trioxide. Here dinitrogen tetraoxide. I hope you might have understood how to name it. If you will write means you will be able to remember some of the names. So please remember this ones. So if however two non-metal element form just one compound, the prefix not used in naming such compounds. Like look here. Here hydrogen. Here sulfur is only one. Na? So are we writing this name? No, we are writing hydrogen monosulfide. Understood? So here beta if it is single, then no need to write. Understood? Directly we are writing hydrogen sulfide. Got it? So magnesium and chlorine is also there. Na? We are not writing dimagnesium chloride. Correct na? We are writing magnesium chloride. Di also we are not writing. So we are directly writing what? Magnesium chloride. I hope you might have understood. Very crucial time. Arunish, Tanisha, you are late. Note down this one, beta. Write this part and just note down this example. I hope everybody understood this one. Come on, we'll go for the next one, please. Yes, I'm going to start the next section, please. Check that one out. So take care of this. So if two non-metal element form just one compound, the prefix not used in naming such compound. The one compound only making then prefix is not used because H2S here now nitrogen and oxygen is making many compounds. Here one single compound is not there. Many compound is there. Magnesium chlorine is not making many compound. So only one compound, magnesium chloride. So that means we cannot say that dimagnesium, trimagnesium, because only one is there. If those people have not understood, I'm going to explain this one. What that means here is, what they're actually trying to say you is, see, here N2O3, NO2, N2O5. Like this means nitrogen and oxygen. These two elements are making many compounds. Nitrogen and oxygen, these two elements are exactly making many compounds. So these two elements are making many compounds. So only we are using prefix for nitrogen also and oxygen also. Are you understanding? So here, because one single is not there, many are there. Na? NO was also there. So that means what? 1, 2, 3, 4, 4 different type of compounds they are making. So if we will say nitrogen dioxide, means is it going to work? No. So at that time, what we are doing, we are using the prefix of this one also and this one also. So what we are writing? Dinitrogen. Very good. Dinitrogen trioxide. Super Sam. And here it is nitrogen dioxide. And here what we are going to write? Dinitrogen pentaoxide. And here what we are going to write? Nitrogen monoxide. Nitrogen monoxide. But beta, for other elements, only one single is there. For other elements, what is there? Only one single is there. So when single part will be there, that time it is not needed to write down. Understood? So like when magnesium and chlorine will be there, so MgCl2 is written. Understood? Not? So we are only saying magnesium chloride. We are not writing magnesium dichloride. Got it now? We are not writing that time magnesium dichloride, or we are not writing many type of cases there, because only magnesium and chlorine is there. Correct now? So water molecule is also only one. Understood or not? So we are not writing dihydrogen oxide. Are we writing dihydrogen oxide? No. Water molecule. Understood or not? So this is exactly the one which is very important to understood. So if two elements are making more than one compound, that time, got it? You are opening in evening time only, so only it is might be possible. So definitely we are understanding here is कि more than one compound will be there, two compounds, more than one compound of same element. Here what are the two elements which is same? Nitrogen and oxygen. So they are making many compounds. They are making many compounds. Then we have to take care of their naming very nicely. Correct na? Because every time the atom numbers are changing. So when the atom numbers are changing, their way of writing is also changing. But magnesium chloride, because only one compound making means we can write like this also. Correct na? Like hydrogen. Are you understanding? So dihydrogen oxide we can say like this for him. But hydrogen peroxide. So hydrogen peroxide and water molecule, they are exactly writing in different format. So we need to understand that section. Now we are going for the next one, beta. Now write this one. This is most important. Yes, I hope you might have understood this one. If hydrogen is the first element in a formula, then no prefix. We are not going to write prefix here. Understood or not? So look here. How this is the most important part. You must remember this one, and it will be used forever. Long time it will be used. You must remember this one, because we are not saying that we are not, hello sir, so we are not saying that, we are just utilizing the content and writing the part. How we are writing the part, beta? Just understand this one. So how we are writing the part? Hydrogen is the first element in the formula, then no prefix is needed, like dry, tri, tetra. 10th class is after this only, beta. 5 or 6 o'clock I'm starting 10th class. Okay, these concepts will be used for writing compounds. They are very important. These are, yes. So now look here, remember this part. So if we are writing H2S means what? Hydrogen sulfide. So here hydrogen is having two. We could have said dihydrogen sulfide, but we are not writing. So whenever hydrogen is written at first, what we are going to write? Hydrogen sulfide directly. Understood or not? So now there are, however, some molecular compounds which will be known by their common name and not by their scientific name. Like water molecule is actually hydrogen monoxide, but it is known in its common name called as water. Now I hope you might have understood, beta, why we are not calling H2O as by their IUPAC name. Have you ever heard hydrogen oxide? No, we are never saying hydrogen oxide. What we are talking always? Water only. You are understanding? So some of the thing which is exactly well known and started from a very long time gap. So we are not using scientific name there. We are not using scientific name there. And that's what we are exactly using the common name. Still what we are using? The common name. So still we are using the name that is exactly commonly given, and that name is water. Similarly, NH3, ammonia, that is called as nitrogen trihydride. Correct name is nitrogen trihydride. That is the IUPAC name. But are we taking it as IUPAC name? No. We are always using it as ammonia. We are always using it as ammonia, and that's the problem. That's the problem. Sometimes, see, sometimes in examination, in competitive examination, they are asking what is the IUPAC name of NH3, and student, they will give both the options. They will write ammonia also, and they will write nitrogen trihydride also, and very clearly the students are writing ammonia and coming back. But ammonia is the common name. The scientific name is what? Nitrogen trihydride. Note down. Nitrogen trihydride is the IUPAC name, and what is the common name? Ammonia. Hydrogen oxide is the IUPAC name, but water is the common name. So this is exactly where the mistakes our students are doing. Are you understanding, Kanish? So this is the most important thing. I'm not only preparing you for what you call general examination, I'm preparing you for competition also. So next time, what will happen is you will have idea of all those things. Correct now? So what is the IUPAC name, beta? Nitrogen trihydride. Nitrogen trihydride. But are we calling nitrogen trihydride? No. What word we are using? Ammonia. But ammonia is not a IUPAC name. Ammonia is common name. Ammonia is what, beta? Common name. Note down. Note down it. This is nitrogen trihydride. What is that, beta? Nitrogen trihydride. What is the name? Nitrogen trihydride, and that we are commonly known as ammonia. Ammonia is the common name. Now we are going to go for ionic compounds. You know what is the meaning of ionic compound? The ionic compounds, that first we have studied about molecular compound. Molecular compounds are exactly made with non-metals. Correct now? Molecular compound is made with what? Non-metals, where we learned how non-metals will be making. So one very electropositive, less electronegative and more electronegative non-metals were helping in making those compounds. I hope you might have understood. But now we are going to take ionic compounds. Ionic compounds are made with ions. It is a purely give and take relationship. It is a purely give and take relationship. No sharing possible. Only give and take. Like magnesium will give, oxygen will take. Sodium will give, chlorine will take. Copper will give, sulfur will take. Understood? So this is exactly considered as what? Give and take relationship. What relationship? Give and take. So ionic compounds are formed by combination between metals and non-metals. Write down. First point, combination. Ionic compound, shortcut way, right? Ionic compounds formed between metals, non-metals. First simple shortcut method of writing. Ionic compound formed between metals and non-metal. Molecular compound formed between two non-metals. Molecular compound, what we discussed? Non-metals. One will be more electronegative, one will be less electronegative. Understood? So metal and non-metal. So molecular compound and ionic compound. Molecular compound and ionic compound. So remember this one. I hope you might have understood this one. So if somebody will be asking you, means you should be ready for answering these questions. If molecular compounds are there, we were discussing that they will be making with two non-metals. But when ionic compounds will be there, one metal, one non-metal. Second important point to be right, then the metal element will be written on left and the non-metal element will be written on right. So metal will be written on left and non-metal will be written on right. Write down. Second point is metal left, non-metal right. Always metal left, non-metal right. You see, this is left side magnesium. Magnesium is metal. Oxygen is non-metal. So what and all things we have learned here? We have learned some very, very important things about ionic compounds. Ionic compounds are formed between metals and non-metals. So ionic compounds are formed between metals and non-metals. Second important point, what we have learned about ionic compounds, ionic compounds, when it is formed between metals and non-metals, metals will be at left side, left side is metals and right side will be non-metals. I am giving beta. And it is right side. In naming of ionic compound, the metal element is named as such, but the name of non-metal element is changed by ide. Understood? So metal, same name. Metal, same name. Non-metal, ide added. Non-metal, ide added. What is added? Ide. Understood? What is added? Ide. What is added there? Ide. So a metal will be renamed as same one, but non-metal will be added as ide. Come on, can we check metal and non-metal? Now let's see one example. So when we are writing an example, you check magnesium oxide. Magnesium oxide. So magnesium is what beta? Metal. And it is placed at left side. Oxygen is non-metal. It is placed on right side. Magnesium full name written. Metal full name is written. And oxygen is written as oxide. Last ide is added. Done? All the 3 points crystal clear? That's what is exactly talking about. So this is, I think everybody, I hope everyone, those who are present here, you might have just understood it in the most simplest way. Ionic compound means what? Ionic compound means ion formation will be there. One will be gaining ion, one will be losing ion. So metal will be gaining ion. No, metal will be losing ion, non-metal will be gaining ion. Metal will be losing ion and non-metal will be gaining ion. I hope, yes. Left and right side, I hope you have understood, beta. Yes, the left side part is there. Shall we go for the next one, beta? So now what we are going to do, we will write the next part. So this is metal and non-metal part. So metal will be exactly making already in the beginning valency is already over beta in the previous part. Ionic compound is exactly made with the help of ions. Okay. Oh, left side part. Left side part. Ionic compound valency already taught till 20. You just see refer the just two previous videos. You will be getting it better. So now look here. Ionic compound. You want me to teach you this, so I am going to start that part. Let's check this one out. So some students who are having doubt, I'm going to clear the doubt first. So now listen. What and all doubt sections are there? I'm just going to first teach you. Now, beta, first doubt. What is your first doubt is ki how you are writing. So now just check this one out. If I want magnesium chloride, MgCl2. Understood? So when I'm writing MgCl2, Mg is 2 plus and Cl is minus. So Mg2, crisscross rule, I'll teach that. Just afterwards, I'm going to teach crisscross rule. But before that, first you understand this one, beta. Understood? So here, look here. So first part is, this is magnesium and this is metal. See how the combinations are actually done. First you understand. I'm telling you the entire section so that one shot itself you will understand and doubt will not be there. In magnesium, outermost orbit is 1, 2, 3, 4, 5, 6, 7, 8. Understand? Or not? And then outermost orbit is how much is there? 2. So this 2 is extra. Understood? And magnesium want to gain the nearest noble gas configuration of argon or neon. Argon or neon? The correct answer is neon. Neon is 2 and 8. So what magnesium will do? Magnesium is a metal. Magnesium is a metal. It will release its 2 electron and it will become 2 electron minus. Done. So here, now magnesium has to combine with chlorine. How it is going to combine? Chlorine, in other hand, needs how many electron? Only one. So chlorine will get one electron and it will become Cl minus. But here, two electrons are free and chlorine is needing only one. So what we will do? We will double the atom of chlorine. So it will become what? 2. So now here it will be exactly 2 chlorine will be taking how many electrons? 2 electrons. It will become 2Cl minus. So now we are writing like this, but here 2Cl we can't write. Understood? Because the moment Cl and Cl will come, it will make Cl2. So definitely it will what? It will make Cl2. Now we are going to make the bonding. So here Mg plus Cl2 plus 2 electrons here. Now here it will become Mg2 plus and 2Cl minus plus 2 electron. So this and this will get cancelled. So what it will come beta? Mg plus Cl2. Here it will become what? Say, because here chlorine is exactly what written, so it will become MgCl2. Understood? So MgCl2, and this is exactly the way to present it. And this is MgCl, so MgCl2. Now, most easiest one is sodium and chlorine. So sodium outermost orbit, how many electrons are there? 281. So now sodium will do what? It will release one electron and it will become Na plus. Got it? And now chlorine is exactly needing, sodium will release one electron. So sodium will release one electron and now chlorine will get this electron, it will become Cl minus. So now what they will become? Na plus Cl plus one electron and here Na plus Cl minus plus one electron. Electron needed over, and now when they will combine, it will become Na plus Cl. It will become NaCl. Compound will be forming like that. So NaCl. I hope everybody understood beta. NaCl. So did you got this point how to get it? Now Ruchi and what you call Arunisha, both of you, can you tell you, did you understood how they are exactly making? Metal will be written first, non-metal will be written afterwards. Now metal valency is very important. First, we are checking the valency of metal, how much. So metal can maximum give how many electrons, beta? Metal can maximum give 3 electrons. Fourth one is for sharing. Non-metals can take maximum how many electrons? 3. Understood? And after that, 2, 1 is lesser one, lesser side only. So I hope, is it crystal clear, everyone? Understood. So this is most important. Note down these things. These things are exactly the pioneer for chemical bonding, and the chemical bonding is possible because of all these factors. So if anybody will teach you all these things, means you have to start from the basic level and you have to understand this basic level. If this basic level is there with you, means nobody can shake your pillars. You will always be saying that, okay, I know the concept first. I hope everybody understood this one, beta. Yeah, I'm moving. Here, this 2 will shift in this side. Okay. Then only it will become MgCl2. Everyone done? These are something very, very important, and it's exactly not present in book. You need to understand all these things. Once your understanding means work is over. I hope understood, na beta. So one is giving, one is taking. One is giving and one is taking. And once they are making, so only they are considered as what beta? Ionic bonds. Ionic compounds are made. So now I hope now, is it easy na NaCl? CuS also easy or not? Copper Cu2 plus S2 minus. S2 minus. So for Cu we'll make one time for Cu. Cupric and cuprous is there. That day we remember na cupric and us. 1 and 2. So cuprous we are going to take. How we are taking beta? So Cu will release how many electrons beta? 2 electrons. So it will become Cu2 plus. Sulfur need how many electron? Sorry. Copper will release 2 electrons. It will become Cu2 plus 2 electrons released. Sulfur is needing 2 electrons. So it will become S2 minus. So definitely this will become Cu and Cu plus S, it will become Cus. Understood? Cu plus S, it will become Cus, and you will be able to solve this one. I hope this is clear. And it is not at all clear. Means writing part. Okay, I'll write there. Wait. See, Cu will release 2 electrons. Sulfur will gain 2 electrons. So Cu plus S plus 2 electrons. Cus plus 2 electrons. This and this cancel. I hope now is it clear? Note down beta. So only I am teaching this one very slowly so that you can understand. Now you are understanding nicely. Any doubt is there? No. Nitrogen, very different names are there. So we are using prefix in that. Correct? Na? But rather than that, we are not using prefix. For hydrogen also, we are not using prefix. Because we are knowing that the hydrogen can be written without prefix also. So without prefix, which part is written? We are not writing that. I hope you might have understood this part. Done, na? Noted? You want to write? They are writing, beta. Offline children are writing. Nice. Good. Written? No doubt? Good. We'll go for the next one. So here oxygen is changed as oxide, chlorine is changed as chloride, sulfur is changed as sulfide. Because metal name will be written as it is: copper, sulfide, sodium, chloride, magnesium, oxide. Understood? How is the chemical formula or molecular compound written? Now this is the major section where you need to understand how is the chemical formula or a molecular compound written. For that, we need to know the structure. Like write the symbol of the constituent element. First, we must know the symbols. So, how many elements are present in the periodic table? Their symbols must be understandable for you. This is the first mantra of writing the molecular or the empirical formula. Understood? Good evening, Ajay. So that's the first important thing, beta. So first, what we have to write, that is the molecular formula writing or empirical formula means whatever formula you are writing. Hey, what is the difference between molecular formula and empirical formula? Re? Last class I taught na chemical formula and empirical formula. What is the difference? What is the difference between molecular formula and empirical formula, beta? If somebody will be asking you molecular formula, then how you are going to write? And if somebody will be asking you empirical formula, then how you are going to write? The system is very simple, beta. Just understand. When you are writing molecular formula, how you are writing molecular formula? Like C6H12O6. This is called as molecular formula. Molecular formula is written in their own format. Understood? But what is the empirical formula? For empirical formula, 6, 12 and 6. Cancel it with 6. So it is coming 1, 2, 1. So CH2O is empirical formula. Did you understood what is the difference between molecular formula? This is molecular formula. So molecular formula will be written as it is, but empirical formula means beta you have to write in the shortest way. I hope you might have understood. Last class also I taught. Again I am teaching this one again. So that's the difference between molecular formula and empirical formula. Now let's go for the next part, beta. So when we are going to talk about this part, we need to understand one by one how to write the chemical bond. Simplest whole number ratio of an atom is called as empirical formula. That's the absolute correct answer, beta. So whenever we are giving empirical formula, that part we are just writing the content as it is, and then we are representing like that. Okay. Now what we are going to do, write the symbol of constituent element side by side. This is the first rule. Now you need to understand that less electronegative will always be present in the left, and the more electronegative will be present in right. This already we have learned. Now valency must be written on bottom of that. Now divide the number written as subsequent. Now let's check this one out. Yes, we are converting the empirical formula in, yes, child, look here. So this naming is very, very important. Let's talk about how we are going to write electronegative and how numbering and naming system is exactly written. And then crisscross. So now I'm going to teach you crisscross rule, the much awaited crisscross rule. Now, beta, in crisscross, you must understand that some people they are writing more electronegative and less electronegative. See, on going from left to right in a periodic table, just understand this one. On going from left to right in a periodic table, electronegativity increases. Electronegativity increases. Understood? So we are saying that left side whatever elements are there, they are less electronegative, and right side, I'm fine beta, god bless you. So definitely that side will be more electronegative. So beta, left side is less electronegative and right side is more electronegative. Now we are going to make one chemical compound with that using crisscross rule. So just check, they have given us two compounds. Understood? Two elements they have given to make a compound. Let's check this one out. They have given hydrogen and oxygen to us, and they told that okay, make a compound, make a molecule with the help of, name beta क्या है तुम्हारा? Hansen. Okay. So now hydrogen and oxygen is there. So hydrogen and oxygen is there. Now beta, hydrogen is less electronegative, so written in left side. Oxygen is more electronegative, so it is written on right side. So now less electronegative left side, right, more electronegative right side. Now what is the valency of hydrogen? The valency of hydrogen is 1. What is the valency of oxygen? The valency of oxygen is 2. Now you cross it. So it will become H2O. That's the crisscross rule. Understood? Understood? So this is exactly coming as H2O. Got it? So this is the way we are writing crisscross rule. How we are writing crisscross rule? I hope you might have understood. Have everybody understood what is exactly? Understood? I hope you might have understood this one. So this now we are going to write. This now we are going to write another one. Let's check this one out. Are you ready for it? Next part. So now let's write the next one. So if less electronegative element we are going to take. So we are writing magnesium and we are writing oxygen. So what is the valency of magnesium? 2 plus because it is giving. And what is the valency of oxygen? Minus. Understood? So here ratio will become what beta? 2 is to 2 is coming. So 2 is to 2, everybody please pay attention here. Whenever 2 is to 2 is there, so what we will cancel, it is coming as beta 1 is to 1. So definitely what it will become, directly we can write magnesium oxide as MgO. Nothing to change here. Understood? So we need to change anything? No, we can't change anything. I hope you might have understood. So now let's talk about the next part. So next part, when we are going to write, just take another example. Okay, more examples we will take, like so nitrogen and hydrogen is there. Got it? Nitrogen and hydrogen is there. Can we talk about nitrogen and hydrogen? So NH3 plus. So here it is exactly going to be 3 plus NH3 plus. NH3 is coming now. Ammonia is what? NH3. So this part is coming as valency is plus 3 and hydrogen is exactly coming as 1. So it is coming as NH3. Crisscross. Done. So this is a way to write. Understood? I'll give more examples. Don't worry about it. More examples I'm going to write and more examples I'm going to give you so that no confusion will be coming. I hope till here you understood or not. Huh? So look at carbon dioxide, carbon and oxygen. So now carbon is how much beta? Valency is 4. Oxygen is 2. Understood, no? So when 4 and 2 will be there, what you are going to write? What is the ratio? 4 is to 2. Cancel, it is coming as 2 is to 1. Understood? So it is coming 2 is to 1. Now this simplest format, it will come 2 and this part is coming as 1. Now cross it, it will become CO2. I hope now you are understanding it. This is exactly the way to proceed and write down. So you must be understanding first ki what is the valency. Once you are understanding the valency, now you need to check which one is more electronegative, which one is less electronegative. Understood or not? And after that, you need to analyze and note down the content. So that's exactly a very important thing to write. So crisscross rule, more example I'm going to give: diatomic, triatomic, tetratomic, that contents were there with ionic pattern when they will be writing, how they're going to. I hope till here it is clear. 5 valency will never be there. Outermost orbit is 5 electrons. So how many electron it is needed? How many electron it is needed first, say beta? 3 electrons needed. 3 electrons needed. So when 3 electrons will be needed, means it will take 3 electrons. Yeah, I'm going to give more examples. We'll do more examples beta. In the content itself, more examples are there. For letting you understand, I started writing here. I hope till here it is clear. Done? Yes, super. So now after this physics class is there, today more classes are there. So get ready for it. रुचि टुडे फिजिक्स में न्यूमेरिकल्स कुछ बता रही हूँ. Now look here, this is exactly, so see, when you will be talking about ionic form, like sodium and carbonate is there. So how we are exactly going to write this? So sodium is +1, correct? And this is exactly how much is there? 2 minus. So 2 will go this side, 1 will go this side. It will come Na2CO3. Note down, it will come what? Na2CO3. Got it? Na2CO3. So how we have written? Sodium carbonate. Understood? Na2CO3. For Na2CO3, when we are writing beta, what we are writing? Na plus and CO3 2 minus. Okay. So the way we are writing, cross we are doing, and it is coming as Na2CO3. Thank you so much. Hate me as much as possible. Then only I will grow. This is my tendency. So now did you understand beta? So subscripts whenever you are writing, then sodium carbonate will be there. Okay, just now 2 minutes I'm going to start. Just one last part we are doing. After that, now you see how we are going to write crisscross rule. Now come on, go for it. Sodium and hydrogen and chlorine will be there. Chemical formula how we are going to write. So next class, understood. So next class what we are going to do, we will be adding hydrogen and chlorine, we will be adding hydrogen and sulfide, we will be adding hydrogen and sulfate, and then we are making, okay, H2SO4, H3SO4, understand or not? So definitely whatever words will be there, with the word we are going to understand how to join it together and how to write it out, okay? Understood now? Boys, so I'm going to keep it till here. Next time having physics class. Thank you so much. Maybe today best non, but next class it'll get it. Thank you so much. पढ़ लो एक बार तो समझ में आ जाएगा आम इमली का मतलब। बेटा तुम जहाँ से निकलते हो ना वहाँ का स्कॉलरशिप लेके बैठी हूँ मैं। ओके, बाय बाय।